23. A car of mass 800 kg attains a speed of 25 meters per second in 20 seconds. The power developed in the engine is, now we know that power can be written as force times distance divided by time or displacement. And force times distance over time. Distance over time is speed or velocity. So we can also write power as force times velocity or speed. So how do we get the force here? We know that F is equal to ma. So we have to get the acceleration from here. Acceleration A is equal to change in velocity over what? Time. So that's going to give us the speed is 25 divided by 20. So that's the acceleration. Now we can now calculate the power. So the power is going to be equal to mass times acceleration. The mass is 800. That's for force. 800 times, that is, I'm writing for the force now. F is equal to what? Ma. So the mass times the acceleration is what? 25 divided by 20 times the velocity. The velocity is 25. Now notice that here I did not cancel, I did not add, because I know fully well that I can cancel from here. So when I cancel out this, I'll be left with 40. Now you see 4 times 25 is 100. So I have 100. I'll add this 0 to it times 25. So what am I left with? I'm left with 2.5. So let me count the number. I'll push this one place back. That's 1 decimal place. 2, 3, 4. So that's times 10 raised to power 4. So the correct option is 2.50 times 10 raised to power 4. That's option. Question 34. When the brakes in a car are applied, the frictional force on the tire is A disadvantage because it is in the direction of the motion of the car. B, a disadvantage because it is in the opposite direction of the motion of the car. C, an advantage because it is in the direction of the motion of the car. D, an advantage because it is in the opposite direction of the motion of the car. And now friction opposite motion, when you apply the brake, it opposes the motion of the car, so it should be in the opposite direction, and that is an advantage because what you tend to do is to apply the brake to bring the car to a rest. So it is an advantage. So option D is the correct option. For 25, if the stress on the wire is 10 raised to the power 7 Newton per meters, and the wire is stretched from its original length of 10.00 cm to 10.05 cm, the Young's modulus is, we know that Young's modulus is equal to stress divided by strain, and we have already been given the stress to be 10 raised to the power 7. So we have to calculate the strain. The strain is extension over original length. Now the extension is 10.05 minus 10. That's going to give us 0.05 divided by the original length, which is 10. So when I divide this by 10, this is going to, I just have to, when I divide by 10, I have to move the 0 backwards. So I have 0.005. So I have 3 zeros now. This is the same as 5 times 10 raised to power minus 3. Now what I will just simply do is this. I'll have, this is the same as 1 over 5 times, now 10 raised to the power 7. When the minus 3 goes up, it becomes plus 3. And 1 divided by 5 is 0.2 times 10 raised to the power 10. Now because of this minus, I'll just move this one this way. I'll have 2, so to put the decimal point 2 times 10 raised to the power. Now I moved it 1 point forward, so I'll subtract 1 from this. That is 9. So my correct answer is option D. So 26. A solid weighs 10.0 Newton in air, 6 Newton when fully immersed in water, and 7.0 Newton when fully immersed in a liquid S. Calculate the relative density of the liquid S. Now, relative density of the liquid S, RD of liquid X, is equal to upthrust on liquid S divided by this upthrust in the water. So the relative density is going to be equal to the upthrust in liquid S is the weight in air 10.00 minus the weight in the liquid, that's 7.0. So I have 10 minus 7.0 is 3 divided by the upthrust in water is weight in air 10 minus 6 newtons. So that's 4. So the correct option is option C, 3 over 4. Then 27. When the temperature of a liquid increases, the surface tension will decrease. Okay. We move to question 28. A gas at a volume of V0 in a container at pressure P0 is compressed to 1/5 of its volume. What will be the pressure if the maximum of its original temperature is kept constant? This is Boyle's law. And we know from Boyle's law, the pressure is inversely proportional to the volume. So let's see. Okay, the initial pressure is P0 and the initial volume is V0. Okay, the gas is compressed to 1/5 of its volume. So if the volume is reduced by 5, the pressure is going to increase by 5 because they are inversely proportional to each other. So if the initial pressure was P0 and this was V0, if this one is reduced by 5, then this is going to increase by 5. So this is the correct option. You can also apply P1. So the initial pressure is P0. V0 is the initial volume, is equal to P2 times V2. V2 is V0 divided by 5 because we are told that it is reduced by 5. So from here, if you cross multiply, you see that this will cancel out this, and when you cross multiply, you see that P2 is equal to 5 P0. Okay, for question 29, a piece of substance of specific capacity 450 joules per kilogram per Kelvin falls through a vertical distance of 20 meters from rest. Calculate the rise in temperature of the substance on hitting the ground when all its energy are converted into heat energy. Okay, since the object is falling from a height, the total potential energy is going to be converted to the heat energy. So I'm going to have MC delta theta is equal to M G H. This follows the principle of conservation of energy. So the energy is conserved. So here, because it's going to be, the mass is going to remain the same, this is going to cancel out this. Here we are asked to look for the change in the rise in temperature, which is same as change in temperature. So we are looking for delta theta. Delta theta is now going to be equal to GH divided by C. It's always endeavor to make the subject of formula before you input your value, make it a lot easier for you to solve. So this is going to be equal to G is 10, and H is 20. 10 times 20 is going to be 200 divided by 450, that's C. So let's see, 0 will cancel at 0. 5 divided by 20 is 4. And 45 divided by 5 is going to be 9. So we have 4 over 9. So the correct option is option B. So for question 30, a liquid boils when its saturated vapor pressure is equal to the external pressure. That's true. Okay, dissolved substance in pure water lead to an increase in boiling point. That's true. Impurity increases the boiling point of any liquid of water. When the external pressure is increased, the boiling point is also increased. That's true. The increase in pressure increases boiling point. Dissolved substance in pure water decreases boiling point. That is wrong. So 1, 2, and 3 are correct. So the correct option is option A. Question 31. The temperature gradient across a copper rod of thickness 0.02 meters maintained at two temperature junctions of 20 degrees and 80 degrees centigrade respectively is. The temperature gradient is given as delta T divided by X. X is the thickness. So that's going to give us, so delta T is going to be 80 minus 20, that's 60, divided by 0.02. To divide this easily, what I'll just do is to move these zeros. 1, 2, I'll now put it up. So I'm going to have 6. I have 60 up before, so I have to add the 2 zeros to it. Then divided by 2. So then maybe this is going to give me 3000, which is the same as, so this is 3000. So to write it in standard, I just have to move this 1, 2, 3. So moving it backward 3 times is going to give me 3 times 10 raised to the power 3. So this is Kelvin per meter. Now, in case you have not come across some questions like this before, at times you find questions like this that you don't even know what they are all about. You can just look through the unit. If you look through the unit, you'll be able to get what you are looking for. Yeah, this is Kelvin per meter. All the units used there are Kelvin per meter. So if they say Kelvin per meter, you know that there should be something related to temperature there. So when you do that, you can easily get the result that you are looking for. Okay, question 32. Calculate the mass of ice that would melt when 2 kg of copper is quickly transferred from boiling water to a block of ice without heat loss. Specific heat capacity of copper is 400 joules per kilogram per Kelvin. Radiant heat of fusion of ice is 3.3 times 10⁵ joules per kilogram. So we have to calculate the mass of ice that will melt. So it's very simple. Now we're going to do a heat transfer. The heat transfer or the heat loss by the hot copper is going to be equal to the heat gain by the ice in melting. So the ice is going to get heat, so that's the reason why it's going to melt at its own boiling point. Now the heat change that's going to take place between is from copper to the ice is going to be from 100 degrees. Temperature change rather is going to be from 100 degrees centigrade to 0, because the boiling water is 100 degrees. So the temperature of the copper is 100 degrees centigrade. So I'm going to have N mass of copper times specific capacity of copper times the change in temperature. The change in temperature is going to be 100. That's 100 minus 0. Okay, let me put times here. It's going to be equal to the mass of ice, I'll call that Mi, times the latent heat of fusion of ice, 3.3 times 10 raised to power 5. So what I'm going to do, I'll introduce the this is 400. Sorry, not the mass, not the mass of copper is 2 kilogram. The mass of copper is 2 kilogram. If I let me just work this out from here, the mass of copper is 2 kilogram. 2 times 400, that's 800, times the temperature change, that's 100. 800 times 100 is going to, I'm going to have 8 times 10 raised to power 4. 800 is 10 raised to power 2, and 100 is 10 raised to power 2. So you multiply 8 by 1, that will give you 8. Then add the powers to it, that's 8 times 10 by 4. It's going to be equal to M1, or M1 is going to be equal to, I'll divide by this. I'll divide by 3.3 times 10 raised to power 5. Now, if you see, if you look at this, let me move this. If I move this forward like this, and subtract 1 from this, I'll be left with 10 raised to power 4. So you see that this is going to cancel out this. I will now be left with 8 over 33. So my correct answer is option 8. Now you see how I did this without even having to make use of my calculator, because I've looked at the option and I found out that the results are in fractions. So that's how I just have to do that. So I have to write this normally, move this one up so that I have the same power as this, then cancel out.